Hi class, today we're looking at chapter 3-5, Nonlinear Functions. Think of a juggler's ball being tossed in the air and falling back down. As the ball rises, its speed decreases. Then it falls and the speed increases. The relationship between speed and time is not always the same. In cases like this, nonlinear functions are needed to describe how variables are related. Nonlinear functions are functions whose graphs are not straight lines. Go ahead and write that down. One example of a nonlinear function is a quadratic function, in which the greatest exponent of a variable is 2. Write that down. So exponent is the number above. So if you have x squared, this is the exponent. And so this is saying that the variable, the greatest exponent of the variable is 2. So 2 would be the biggest that it would have to be a quadratic function. Okay, the graph of a quadratic function is a U-shaped curve called a parabola. The curve may open upward or downward. So it could go upward or downward. When you throw a ball in the air, the path it follows is a parabola. Okay, so looking at these graphs, which graph appears to be non-linear? Well, the graph in function 1 is a straight line. And we learned in previous lessons, straight lines are linear. And the graph of function 2 and 3, that is a parabola, so that one is nonlinear. And this one does a wiggle in the middle, also nonlinear. So function 2 and 3 are nonlinear. Okay. So sketch these points. Does the function appear to be nonlinear? So this is x going this way. This is y. Okay. So x is 2. 1, 2. Y is 4. X is 4. Y is 8. X is 6. Y is 12. X is 8. Y is, sorry, my numbers got in here, 16. That looks pretty linear to me, right? So does the function appear to be nonlinear? No. It is linear. It's a straight line. Okay. Identify nonlinear functions from equations or tables. If a function greatest exponent is 2 or greater, or if it has a variable for an exponent, it's nonlinear. If the ratios between the change in a table is not the same, it's nonlinear. And we touched on this a bit last week. So determine which function is nonlinear. Well, it told us that if the exponent is bigger than 2, then it is nonlinear. So this one for sure is nonlinear, just because of that. This one over here, if you multiply that out, we're going to put this in here and here, then we get y equals 8x plus 8 minus 1. Combine like terms, y equals 8x plus 7. That doesn't meet any of the criteria with exponents. Therefore, this one is linear. So it's asking us which one was nonlinear. This one is linear, so that one is not nonlinear. Looking at this chart, it said that linear has a similar pattern. So let's look at the pattern. 2 to 4 plus 2 plus 2 plus 2, right? 4 plus 2 is 6. 6 plus 2 is 8. 10 to 7, that's going to be a minus 3. 7 to 4, that's a minus 3. 4 to 1, that's a minus 3. Ooh, so these, negative 3, 2, negative 3, 2, negative 3, 2. Those are the same. This is linear, and we're looking for something nonlinear. So that's not it. Let's look at the next one. We have 1 to 2, that's going to be 1. 2 to 3, that's 1. 3 to 4, that's 1. 1 to 8, that's 7. 8 to 27, that's 19. Ooh, already we can tell that's not linear. So therefore, this one is nonlinear, and that's what we're looking for. Okay, so go ahead and try this next one on your own. This, I messed up with my notes. This should be 4, scratch that out, 4 with an exponent of x, which already they said if it has an exponent as a variable, and that's an x, then it is nonlinear. So sorry, I'm already giving that one away. Okay, so see if you can figure out with this table which one is nonlinear. Okay, you should have got that the top one was nonlinear. The 3 was different than the other ones that just had 2. And then this one down here was 1/3, 1/3, 1/3. So that one is linear. Nonlinear functions from descriptions. So decide if the function is linear or nonlinear. A single cell division divides to form 2 cells after 1 minute. All cells formed after this divide in 2 every minute. A function relates time in minutes to the total number of cells. So what do we think? Is that linear or nonlinear? So as time increases by 1 minute, the total number of cells double, which is not the constant rate. So it's not like we can just multiply something to do it, because it's however many we have are doubling. So the function is nonlinear. Okay, now you try this one. Okay, so you should have got no, and it says to explain. So as time increases by 1 hour, John's earnings increase. So that means it's going to be a straight line. Every time it comes over an hour, it goes up. And therefore, it is linear. And the question asked, is the function nonlinear? So no, it is linear. Okay, so please do page 106, number 4 through 15. Complete all the problems, both even and odd. It's only 11 questions. Happy homeworking!